This is new to me. I am becoming old. So it's like pop, but also EDM, hip hop, and electronics. It's like everything basically. Weird. And rock. Interesting. So UK based. Today we're going to talk about uncertainty in data mostly. Let's start by looking at this. This is a chart that I screenshotted from the a website that aggregates Canadian polls on preferences over different parties in Canada. So there's conservatives, liberals, NDP, etc., etc. I don't even know what the rest are. So I have a question for you all. In this chart, which one do you think is leading? Conservatives or I am not sharing my screen every time this happens. Good. You know why I make this mistake every time? Because I am looking at my OBS. It's Maddie's fault. She reminded me. I blame you. There, I gotta do some sort of blame game because if I make a mistake, what, 5 times? It's either I'm stupid or it's your fault. Okay, good. Every time. This all goes onto YouTube. Receipts for my perfect attention sometimes during class. Anyways, so yeah, today we're going to talk about uncertainty in data that we collect and we see. So I screenshotted this visualization from the website that aggregates Canadian polls on different parties. So this is conservative, this is liberal, this is NDP. And the question I have for you is, in this chart, which party do you think is leading? Okay, conservatives. That makes sense. Why? Okay, highest polling average. Sure. Okay. Okay. Good. Good. Okay, good. I like these responses. So we are saying higher up in the chart, highest polling average. Conservatives, however, it does not say what the average is taken from. Let's just say polling averages, meaning they've had a bunch of polls and these are averages of those averages. Okay. Okay, we're going to talk about this a little more. How about this? This is in 2024. So look at the time. This is before like closing to the elections. Which one do you think is ahead? Yep. What's the difference between this chart and the previous chart? This one and this one. Yep. Larger gap. Larger gap. So it seems based on polls in 2024, conservatives were just far ahead, 20 percentage points ahead. This was close to the election. Which one do you think is up? It's a trick kind of a question, but I think based on your answers, closer to the elections, liberals were up, right? Is that your answer? Looks like, yeah. So, did any of you consider what these colored bands are around these lines? That's a good guess, max and min. But these have different names. The brighter lines are those averages, but those areas are the error bars, or these are like confidence intervals, or things where these are their confidence of the people who took the average that the true average lies something in this area. When these two bars are overlapping, essentially means that there's not really a, there is no noticeable difference between these two averages, even though visually one is higher than the other one. They're so close, and you might have heard it within the margin of error of each other or something. You've heard this, but our brains just automatically goes to those lines. It's so hard to have your expertise show up, even though you've heard this, the notion of margin of error, even though it's shown here. So you might have asked, okay, what is this area that you're showing us? But you went with the lines. This is the chart says polling averages, and we all do that. So this is what I'm talking about. There is uncertainty, right? Sometimes the uncertainty is shown in visualizations. And this is how you might or might not interpret it. So today I want to learn a little bit, at least gain some intuition about what uncertainty is and how you might represent it visually. Okay? And there's uncertainty everywhere, and you might have uncertainty in your beliefs and how you think about stuff. If I ask you how, you know, that question about AI, right? You might not know, right? Even though I asked you a question saying, how likely do you think this future is going to happen? You might say, hey, I think it's likely, it's 50%, but I'm just not sure. It could not happen. I don't know. You might be uncertain as well. So let's now recap a little bit before we get to the uncertainty. So we've learned in previous sessions what averages are, right? What medians are, what modes are, quartiles, percentiles. We've learned about centrality and spread, right? Those measures that help us describe a data set. And we also learn how to describe them visually. So we learn how to draw a histogram that showed us how many data points are within a specific bin. And we learned that we call this data set a multimodal or a bimodal data set that has two peaks. We also learn how to create a box plot, and that this is the median, this is the 75 percentile, this is the 25 percentile, and these are the anomalies. Okay? All right. However, now we're getting to something really important. A notion that you might have heard, and you need to start thinking about what they mean when you look at a data set, especially data sets that are polls, data sets that are about opinions, just anything that's a collected data. We have this concept of a population. This population is not that count of people who are in a country. This population is all of the data points for the set we are studying, right? So if we are studying our class, the students in the visual analytics course in School of Interactive Arts and Technology, the population under study would be the 50 something students that are in the class. Okay? If you're looking at Canada, the population you should study is the population of Canada, right? And so far, so it is how you think about it. That is a population. And then we have a notion of a sample. That is a subset of that data set. I wrote data point, that's wrong, data points. So that's a subset. The sample is the number that you have access to, right? The number of things that you're looking at to make sense of the whole population. Usually you sample because we are not always able to look at everything. So let's say if I want to see what the opinion of this class is on this question, right now I have a sample of 17 people from a population of 50. And maybe I can use this sample to make a guess about what my class's overall opinion on this matter is. Or you could use this as a sample for Canada. This is a sample of Canada, people who live in Canada, right? So you could use it. I don't know if you trust it, but your intuition might say, oh, 17 is not enough. Why isn't it not enough? That's a question that we're answering today. Okay? With the population, if we have all of the data, usually we know all of the stats. So like when we say the average height of this class is like a number or the average opinion about something, then we assume that is the true stat mostly, but not always, because errors exist in data collection as well. And people might just give you wrong information as well. So there's sources of mistakes in data collection, But usually you say, okay, this is as good of a statistics about a data set that I can know. So you can trust that, say, okay, the height of this class is, I don't know, 6 meter or 5 meter or something. Okay. And then same goes for Canada or countries. That's why when you have the census happening every 5 years, those numbers are a good representative of those values that you're getting. So like you get median income, all of that is a little closer to the truth, to the facts on the ground than when some agency goes and collects data from 50 people. Okay? So let's say, remember we asked the question approximately how many days has it been since you've watched a movie? For the whole class, the median was 27. The mean and the median was 9. And this was the box plot of your responses the first day of the class. So there's one person who is an anomaly that hasn't watched a movie all year. But most people have watched a movie here. Okay? You can read this chart now. Now, when we talk about a sample again, we have access to a subset of the data set. Then the stat, mean, median, etc. of the sample is not equal to the mean of the population. It is not, because you don't have access to the whole thing. So when we calculate stats from the sample, we have a degree of uncertainty. We don't know the actual truth. It's just a sample. Now, there's this idea that if it's a representative sample, if it's a random sample, then you can trust it more because random things are more likely to represent the whole population. But maybe the people who show up in my class for this optional lecture that is later on YouTube is not a random sample. Maybe these are more interested in things. Maybe you are the more interested, or maybe you are just randomly the people who have the time. We don't know. But so when you think about samples, you also think about how that sample is collected. So this is the actual data that we show, and we're going to repeat this exercise with the response you gave me. But like when we have a sample 5 from 29 responses that we took, the sample mean is 13, but the population mean is 27.5. So it's different. You can guess why, right? Because there's a bunch of things that are not chosen in this sample. If we change the sample, it's still 5. The response would be different because we're taking a random sample, right? So you will have a different number. And you can repeat this, increase the sample size. Then the sample mean becomes 20.9. It seems to be closer to the actual mean. You can increase it again, and this becomes closer and closer to the actual population mean. Okay? So it's like that. So the idea is that the larger the sample size, the more confident we are in our estimates. Okay? So essentially, when you make an animation like this and you keep repeating a sample, you can see that why the uncertainty exists. Okay? Because sometimes it's 365 is chosen, sometimes it's not. So the numbers move around. So I want you to always visualize this in your head. Whenever someone shows you a poll or someone tells you, hey, my uncle smoked cigarettes until he was, I don't know, 90 and he didn't die. I want you to think about, oh, that's just one sample from a whole population. Maybe that's not generalizable. Okay? This is the most extreme example of a sample is just one experience. That's called an anecdote. Okay? So if you have this experience and you think it's the truth, sometimes maybe you should just consider or reconsider whether that is generalizable to the actual population, whether that is an opinion that you hold that could be expanded. Rio has asked a question for which oh yeah, that's I just forgot that is this is from before. Okay. So now this is another example to just show like when we increase the number of samples, the mean of that sample, the average of that sample gets closer to the actual population. It just becomes less uncertain. See, in the beginning, we've this is only one, and see, it's just way different from the actual truth. But then you move it around, you keep adding samples from more people, and you get closer to the truth. Still, there's uncertainty. Still, there's these errors in our collection. But the more you go, the more you'll have it. This is another representation of it. But this movement, I want you to remember this movement, right? Because this is how data science usually is, how data statistics are, right? Usually you have these sorts of movements, these random things that happen, even though you want to believe or you want to show that this is the truth. It's not always the case. There is uncertainty. So not only it's important to show uncertainty, but I just want you to remember understanding uncertainty is also important in general. And it's something that I highly suggest you all do. Okay, now let's look at these responses. I'm going to do this live again. So I created this little app. Hopefully I can just copy this and load data. Perfect. Okay. It seems like we were able to collect this data. Okay. So now I have collected a sample from my class. I just want to see for the question, how likely do you think that AI becomes as creative as humans in the next 10 years? These were the responses. We have unlikely, super, like no chance at all. We have 50-50. We have people who say, oh, it might happen. We have 75. We have these different responses. Oh, there's more. We have 100. Okay, we have 55. We have 2. 2 is just very close to 0. So we have these distribute like this, and this is another representation of it. Okay, so the average of the 17 is that on average, people think it's about 35% likely or something. It could one out of 3 times it could happen. The median was 30 and the standard deviation is 30. Okay, now let's practice with this, what we just learned. So let's just reduce the sample size to 5 and see what happens. Okay, so now we've picked this specific sample. We have picked 20, 60, 45, and 5, and 100, right? So the average that we take from the sample is 40, even though the population is that. So the mean that we're taking from the sample is different. And then we can keep resampling, and you can see that the mean keeps jumping around, even though we know that what the truth is. The truth for this sample is 35. It just keeps jumping around. And sometimes it could be way off. Could be just way off. Okay? Now let's increase it to 10 and then look at it. Because we have more samples, usually it's closer to the true mean. And if we increase it to 50, then it's just very close usually. Okay, sometimes it's even on the mean or something. Yeah, hopefully just with this example, you get a sense of what this class today thinks. But can someone tell me, can someone from the 0 side type in why you think there's no chance that AI becomes as creative as humans in the next 10 years? They might be typing. AI is likely peaking. Bubble will burst before enough compute comes online, my opinion. Okay, I like that. So whatever we have, you think that's the peak. And assuming, that's an interesting question, but assuming that this is not true, you think if it was going the same direction in terms of progress, it could become. Someone says, I was the 10%, and I think comes down to the AI being misunderstood. AI as we know it, just search engines rehashing stuff. Yeah, that is a good way of, to some extent, that is true. Yeah, it's a bit more complicated than that, but yes, I agree. So I don't think it can become as creative, right? Me neither. I'm closer. As the internet gets taken over by AI content, the training source is contaminated. So you think it's just going to even get worse, right? It's just going to get all bad, even though it might be, I don't know, 10% creative. It's just going to get even worse. Anyone who responded 100, yeah, we'll have a separate, maybe the day that we all hang out, that'll be one of the points of the discussion because that day is coming. Maybe after the midterm or something, go to a bar or something. Anyone from the higher 70s and hundreds and 60s? Anyone want to represent that side of the opinion? No? To below 50. Did something change your opinion because the discussions changed your opinion? But what was the reason when you gave the response? It's okay. That makes sense. But what did you have in retrospect? What was your rationale then? Yes. So Simon says, I think AI gives the illusion of creativity. Who knows where it will be in 10 years, but I don't think it will achieve the level of creativity ingrained in humans. Sounds good. Okay, this is not the topic of this class. However, I have the reason I want to bring this discussion is okay, let's see. I gave 20%, and it's because I think AI is just really good at taking already existing information, rewarding it, and just outputting it. I don't think it has that capacity. I saw a Sora video of them mashing the peanuts with the Prince of Egypt, and that was looking pretty legit. AI will always be artificial. Creativity is an organic concept. Okay. So I like the diversity of opinions that are in this class. And I want to actually talk about for a moment about that Sora idea. And I think it's hella impressive, crazy impressive what they have been achieved. When I was a PhD student, this was not possible. And I did not think it would be possible this fast. However, I am also pissed off usually because I just don't think, I think most of the videos are like, we can get into a discussion, but like they are sort of interpolations of existing ideas or of sorts. Like they can make pretty good. Yeah, they could put peanuts with a Prince of Egypt or something. These two concepts exist. They can mash them together, but or they can make me look like a Miyazaki anime or something. But that's already been done. It doesn't make my soul warm or something. Yeah, the reason I brought this discussion is that even as you can see that there is a diversity of opinions in this class. So we can now assume that 17 out of 50 is a big enough sample of the class, okay? To tell us what this class thinks. So you can basically, the idea is that there are a lot of different ways to take a sample. And again, this is not a stats class. I just want you to get the intuition. I'm not teaching you stats. That's why I'm trying to show this to you visually. But you can take this opinions from this class, right? That'll, let's say 17, and you can just keep taking from that 17, right? With replacement. Let's say first time I take 3 times Theresa's response, and then 10 times, I don't know, 2 times Michael's response, and then put them together and calculate a mean. This is called random sampling with replacement. Process is called bootstrapping, right? So you randomly select it, and then you calculate the mean of that random sample, and then you write down that mean somewhere. And then when you've done this a bunch of time, you can calculate how wide those means were, what was the coverage of that. And then that gives you a sense of the uncertainty, assuming that you want to calculate the randomness, the population mean. It can tell you the error bar or that confidence interval that we looked at. So you can look at different ways that you can calculate this, but like visually, it would probably look something like this, right? Having all of these, you will get a range like this. So it seems like this class has like an opinion between 50 and 20 based on this method that I just explained to you, right? If we had reduced, this would look similar, but it would change. So even the way you sample from a class or from a population changes how the uncertainty is represented because you don't have access to the full data. Anyways, but it gives you a sense of uncertainty. But the reason I'm showing you this is that maybe 17 out of 50 from a class that are all SIAT students would be a good sample. Maybe it is random, maybe it is not, we don't know, but it's decent enough. Maybe this tells us what the range of opinions are within our class. But you probably wouldn't do this for Canada for a variety of reasons, because probably SIAT students have similar characteristics. They're all, I don't know, more nerdy than the average Canadian, right? They like video games more, they like anime, they're interested in design and technology. There are traits that you have. So that sort of biases this data set that we are collecting, and that you would not use that for the opinion of all of SFU, even, let alone just the whole Canada. The whole of Canada, right? So if you want to know the opinion of SFU, then you would have to somehow randomly sample from all students if you want to take opinions of students, and then get their opinions, right? So there are all these different types of biases that happen. That also introduces uncertainty, because that means the data is wrong. Okay. I will share this code for you later. I've been working on it in the past couple of days so that you can look at, just play with this idea of you can generate a lot more random data, right? And then increase the sample size just to see how much it gets closer. See, it just gets closer to the actual mean. And then you can click on resampling, and then you can also calculate a uncertainty interval for that. Okay. And then go look up bootstrapping. It's an interesting method. You could use it if you want to use it for the final project or something. Okay. Hopefully this gave you a sense of what it means when we say data has uncertainty, just through a simple example. But again, this would be a way that you would calculate the means of means, right? So then usually this is how we define things, right? We have a mean, and in most of these, and we have these confidence intervals, which tell us how sure the presenters of that information, based on that methodology that they're using, are in the statistic they're giving you. So in elections, you'll see these, right? Someone tells you Trump's chances versus Hillary in 2016 is 28%. So Hillary is 70% likely to win. And New York Times says 15%, Huffington Post says 2%. The other problem with uncertainty is that when you hear numbers and percentages, it's harder for people to think in those terms, right? So now we're getting to idea of representations of uncertainty. If you tell me there is a 30% chance someone is going to win, I'm like, I would not put my bet on it. That number is not impressive enough. It's just not as interesting. So a lot of people were super pissed at these pollsters because they saw their uncertainty representations, and they said, oh, you said Hillary is 80% likely to win, but Trump won. However, if you change the representation, now let's imagine you go to a movie theater close to Seattle, right? On a Friday night. And then how likely do you think it is to see just randomly people? 28% is like close to 1 out of one out of three. There's close to one third, right? So if you imagine you knowing one third of a movie theater, you go there, how likely for you is it for you to see it? You probably, it's likely to for that to happen, right? So changing this visual representation from numbers to these frequencies and these analogies might help people better understand what the uncertainty in the outcome is. So this 28% is this visualization. It's big enough. This 15% is still big enough. Like, I would not be surprised that I might know one of these people if there was a 15% chance to see it or something. Anyways, so this is called frequency framing, right? So people are generally good at ignoring uncertainty, and we just saw it, right? Especially with numbers, and like percentages are harder for people to understand. But when you say 5 in 20 or 5 in 10, then it becomes just easier for people to get it. It's more close to how we think. I always, my thought is that it's because of the fingers. This is called frequency framing, and sometimes you want to use that type of representation. However, there's a bunch of different types of representing uncertainty. There are like these box plots, that is a way of representing uncertainty. There are bars, you might see them in academic publications. There are violin plots, there's swarm plots, there's these gradient plots that show where it's more likely and where it's less likely based on the methodology. So you might, I've put papers for you to look at if you're interested. So you can think about them in terms of glyphs and summary plots. That's the way it gives you a sense. We've already learned about error bars and box plots, but then you can also have visual variables impacting that. So using lightness, value, area, or blur, and then just a set of examples from that sample that you have, you can show uncertainty, right? So this is discrete outcomes. This is using sort of visual variables, and this is using glyphs and summary plots. So coming back to this, going to these different election forecasts, you might even see these sorts of plots. And it says, oh, 95% of outcomes fall in this range. So it is explaining to you what uncertainty is, okay? And this is also another, see, this vote share, they're so close, but they're also putting you these numbers, right? They're saying, oh, like Republicans are two points ahead or something. Even with these representations, people are still like not great at understanding uncertainty. So like one of the most interesting points of not like this ignoring uncertainty is with these bars. So if you like draw a bar and just draw your error plot on top of it, people are just going to ignore these lines. People are going to see this value as the last date that someone read a book in this class. They're not going to see that, oh, the range is really wide, so there's uncertainty in this data. So you like, it's just the same as just not showing it almost. And the same goes with these types of, people were mad at New York Times for this. This was an animation where, look it up, it's called Needle Plot. There's like stories about it. Okay? And then this used to be animated. I can't find it, but it's similar to what we did here for representing uncertainty. So instead of just showing like a static representation, you can also just do this. You can just create an animation that shows like future outcomes, right? Just by resampling. And that is an interesting way of representing uncertainty. Maybe in your website or in your examples, instead of drawing it, you could just create a chart, and they call it hypothetical outcome plots. So each frame shows you an example of what an outcome could be. So in your code, you could simulate this process and just keep showing this as an outcome that could happen, or a sample that could be reasonable. So the takeaway from today is that it's important for visualization designers to represent uncertainty, especially when it comes to polls, science. I don't know, you might become, go work at a company and they might do a survey. And it's important how uncertainty is represented. People might misunderstand it. People might get angry at you. So take these two takeaways. Remember a little bit, just have a little bit of intuition about how these different ways of representing uncertainty happens. Frequency framing is a good idea in general, but in different scenarios, you might want to do different things. But in your life as well, let's in your life as well, just try to know that sometimes the data that's given to you is not the truth. It's an uncertain representation of the truth. And even truth could be manipulated. With that, I think that's enough for today. And we will post this video tomorrow, I believe. And hopefully, see you on Monday. Monday, we'll have a shared, less of a lecture, and then we will be able to get more out of this. We're cooking up an AI and data visualization lecture for you, Mehdi and I. Soon it's coming. All right, bye.